First thing I want you to recognize, look at the second sentence. This can only be used when there is no bx term in your formula, in your equation. Okay, so this means you have x squared, whatever your letter is, and you have another number. And we don't have anything else. That's what we're looking for. So if you notice, none of these have a next term. You look at 4 and these down here, there's one in parentheses, but if it's all in parentheses squared, we can still take the square root of it and do away with the square. Okay? So this is what we're looking for. So if you look at number 1, it says find the solutions. Anything that has x squared is a U-shape. Most of the time we have 2 answers, so we're looking for 2 answers here. You do the same thing to both sides. Opposite of squared is square root. So we're going to take the square root of both sides. And I want to write it right there so that you remember. Square root of both sides. Just like I said, squared is the opposite of square root. They're inverses. So, if I take this, it cancels out everything but the x. What's the square root of 36?
6.
Plus or minus 6. We've got to have both. Because 6 times 6 is 36. Negative 6 times negative 6 is 36. So, there's your answer. On number 2, is x squared by itself?
No.
No, we got to get it there. So first thing, x squared by itself. Then we can take the square root of both sides. So just like solving any other equation, how do we get rid of minus 5?
Add 5 to both sides.
So we're going to add 5 to both sides. X squared equals 23. Then, since x squared is by itself, I can take the square root of both sides. If I take the square root of anything squared, cancels it out, I get x. Can we take the square root of 23?
No, ma'am.
I'm going to leave it. Notice the difference. On the first one, did we take the square root of 36?
Yeah.
Yes, there is no square root sign on your answer. Number 2, did we take the square root of 23?
No.
No, there's a square root sign left on your answer. Okay, if you did the operation, fine, you've got an answer. If you didn't, you have to leave it. Okay, so, same process, look at number 3. We're trying to solve for x squared.
Subtract 15.
We got to subtract 15 from both sides. 2x squared equals 6. How do we get rid of the 2?
Subtract.
There's no additions.
Right.
Just the 2. That's 2 times, so what's the opposite of times? Divide. Just as if you were solving. Everybody's attention should be up here. So x squared equals 3. Now, since x is by itself, x squared is by itself, we can take the square root of both sides. Can we take the square root of 3 without getting a decimal? Nope. So we're going to leave it. Plus or minus the square root of 3. Again, we want 2 answers because most of the time it's going to cross the x-axis. Okay, we have some instances that we don't have a solution or it doesn't, but all of these we are. So the whole idea is if we can recognize that we have something squared, then we can make ourselves problems a lot easier. Okay, so let's look at 4. We're going to do the same thing right here. That x minus 5 is stuck together in that parentheses. So if I want to get rid of the parentheses, I can take the square root of both sides. That's going to do away with the squared. All we're left with is x minus 5. That's the whole point. If it's on that same key on your calculator, okay, those are inverses.
X minus 5 squared.
So, what is the square root of 49?
7.
Positive or negative 7. Because 7 times 7 is 49, negative 7 times negative 7 is 49. Now, what are we actually trying to solve for? X. So we're not quite done. We're almost done. So if I want x, what am I going to do with this 5?
Add 5.
Add it to both sides. Okay, but you got 2 choices. Okay, just like on the quadratic formula. What's 7 plus 5?
12.
12. What's negative 7 plus 5?
2.
Negative 2. So there's my answer. Remember, our answer could be a positive 7. So if I add 5 to positive 7, I get positive 12. Or it could be negative 7. And negative 7 plus 5 is negative 2. We have those 2 choices. If I looked at that picture, we would have something look like this. We would have a negative 2 and a positive 12. That's what we're looking for. Okay, so let's try 5. We got 2 sides of our equation. We want to get, before we can take the square root, we want to get this by itself. So if we look at what we've got, what do we need to move first? The 3. We always undo addition or subtraction first. So if I add 3 to both sides, one step at a time, what's 21 plus 3?
24.
24. Kind of like unraveling it so we can get down to one thing. How do we get rid of 4? Divide. So we get rid of the 4. We've got our x minus 3 squared. What's 24 divided by 4?
6.
6. And now, we can take the square root. Up to this point, you've done this since 7th grade. Solved equations. Now we're adding one step to say, okay, how do I get rid of a square? I take the square root of both sides. So I'm left with x minus 3 equals, can we take the square root of 6?
Yes.
No, without getting a decimal, right? We don't want a decimal because none of those numbers go into it that are perfect squares. So we have plus or minus the square root of 6. So we're just going to keep it, just like we did on 23. So now minus 3 here needs to move. We're going to add or subtract it.
Subtract.
And
It is being subtracted, so I'm going to add it. So my final answer is plus or minus the square root of 6 plus 3. You can't combine those. We can't get 9. We can't do any of that. If you needed a decimal, you could go to your calculator, say square root of 6 plus 3, get your round your answer. Negative square root of 6 plus 3, round your answer. Okay, but for me, just leave it. If you notice at the top of that, I'm not sure if it says on the top of that one. I think it says, no, it doesn't say round there. On your worksheet, it says do not round, which means we want an exact answer.
Okay.
Okay, so I want you to try number 6.
Oh, I got it right. Let's go.
Okay, so we got to right here. We took the square root of both sides, and then we end up with plus or minus 7 plus the square plus 3. Okay, and we're going to leave it.
Yeah.
Okay, now, they're not always difficult like that. Think about this last one. If you want x minus 3 by itself, what's the only thing you need to do? No? Divide by 5. So, Divide by 5 on both sides. What's 20 divided by 5? 4. Okay? So you don't always have to add or subtract something first. You want x minus 3 squared by itself. So if I take the square root of both sides, we've got x minus 3. What's the square root of 4? So we have plus or minus 2. And we want x by itself, so I need to add that 3. So remember, we got 2 answers. If we use positive 2, what's 2 plus 3?
We got X minus.
This is what we have. What's 2 plus 3? If we use negative 2, what's negative 2 plus 3? Positive 1, because you've got 2 plus 3 or negative 2 plus 3, because we got to use either one. So there's my answer right there. So on every single one, we're going to be getting it down to where we can take the square root of both sides, and then get your answer. If you end up with something under your square root that is a negative, make sure you work the problem right, okay? But if you did, there's no solution. We can't take the square root of a negative number. That would be a graph where your parabola is above or below the x-axis. Okay, there is no solution if you come up with a negative. Same thing when we did the quadratic formula. Okay.